The calculated rate at which the universe expands is probably wrong, and scientists do not seem to have an answer why. But why is the rate of expansion of the universe important? The values of the Hubble constant gives us the idea of how old the universe is, and the shape of the universe, whether it is flat, spherical or parabolic, and also gives us insights on the fate of the universe, whether the universe will keep expanding, or will the expansion slow down and the universe will collapse on itself. Launched in the year 1990, the Hubble Space Telescope, along with other missions, was also tasked to find the rate of expansion of space, also known as the Hubble constant. The Hubble constant is the quantity that sets the scale size and age of the universe. It's a measure of how fast the universe is expanding at the current time. It is measured in 3 steps. First, the Hubble Space Telescope is used to locate a type of star in our own Milky Way galaxy, known as Cepheids, which alternately glow and dim. With the help of the parallax method, the distance between Earth and the Cepheid is measured. The knowledge of the peak observable brightness of Cepheid and their distance from Earth is used as a yardstick in the second step. Here, the telescope is pointed to another galaxy containing similar Cepheids. The predetermined values are used to predict the distance between Earth and the new Cepheids. Also, distance of exploding stars, known as Type 1a supernova, is calculated along with their peak brightness. These values are used to calibrate a new, second yardstick. In the third step, the Hubble is turned to direction which looks far into the edge of the universe, where it is expanding. At this distance, Cepheid becomes invisible and only supernovas are observable. With the second yardstick acting as calibration, we can find distance between Earth and a galaxy nearly at the edge of the universe. Now that we have the distance, we need the velocity of the galaxy, which is measured with the help of the Doppler effect. Now, if we divide the distance between the farthest galaxy and Earth with the velocity of the farthest galaxy, we get the rate of expansion of the universe. Calculations till now have shown that the Hubble constant is 73 km per second per megaparsec. Which means, for every megaparsec, that is 3.26 million light-years distance away from Earth, the universe is expanding at a rate of 73 km per second. There is one more important thing to know about the Hubble constant. Although we call it a constant, the value of the rate of expansion of the universe changes with time as the universe expands and matures. Coming back to the topic, the rate of expansion of the universe is also calculated by another method. The European Space Agency's Planck mission and the Atacama Cosmology Telescope were used to study the cosmic microwave background. This study gave us an idea about the state of the universe, just 300,000 years old. The microwave background is not uniform and varies across the sky. Data gathered from the Planck and Atacama Cosmology Telescope were studied for over 2 decades, and the variations in the microwave background were measured. The measurements of the variations give us the idea of the age, shape and density of the universe. Along with these, it also tells us about the rate of expansion of the universe. Hubble constant derived from the cosmic microwave background is 67.5 plus minus 0.5 km per second per megaparsec, which is slower than what we calculated with the help of the Hubble Space Telescope. This disconnect between the data from the local universe measured by the Hubble Space Telescope and data measured by the Planck and Atacama Cosmology Telescope from the cosmic microwave background has left us with no explanation. Even scientists are unable to answer this mismatch. This could mean 2 things. Either the data and the calculations are inaccurate, or the universe is trying to tell us something, which might lead to discovery of new physics. We might find more answers from the recently launched James Webb Space Telescope and will probably be able to solve this mystery. That's all for today. If you are curious about the James Webb Space Telescope, check out our video on it. And if you enjoyed this video, then like, share and subscribe to Explify.